The following video demonstrates an advanced post-processing technique unique to Vericut Icam Post. This feature, called Limit-Based Cartesian-Polar Switching, can be activated in operations where the tool axis is parallel to a rotary table axis. In these cases, it becomes possible to use this rotary in place of one or more linear axes when positioning from one position to the next in the program, such as during a drilling operation. The window on the left is the runtime module of Icam Post, Jenner, currently set to execute a post processor configured for this Mazak Integrex mill turn. Like most mill turns, this machine has limited x-axis travel below the center line. Let's execute the post by pressing the play button. When the post starts, a dialog box opens up, allowing for two runtime options to be selected. First, let's not check any of these options. Let's take a look at the output generated by the post. Because this machine uses two channels, the output window is split in two. Notice the Integrex setup blocks and the visual synchronization between channels. We can simply reset the model in Vericut, as the project is already pointing to the NC program produced by the post. Let's now start the simulation. This operation drills multiple holes on the face of the part using x and y axes Cartesian positions. After a few holes, the x-axis needs to reach below the center line, which generates multiple out-of-travel errors and even collisions with the lower turret. This program is definitely not going to work on the machine. Let's return to Jenner and rewind the post. Then, execute it one more time. This time, let's check the first runtime option, which enables reactive limit-based polar positioning. Once again, let's reset the model in Vericut, then run the simulation. Notice that each time the x-axis is about to position below the center line, the post avoids the overtravel by moving the c-axis. This is the post's reactive method for eliminating overtravel. This option allows the program to run on the machine without any reprogramming. However, Icam Post offers an even better option. Let's rewind the Jenner window and execute the post again. This time, let's check the second runtime option in the dialog to enable proactive limit-based polar positioning. Again, we can reset the model and rerun the simulation. Notice that at the start of the drilling operation, the c-axis rotates to a position of 123.875 degrees. This is because Icam Post has determined that this particular orientation brings all the holes above the center line, making it possible to drill them in Cartesian coordinates. Therefore, no further c rotation will be necessary.